Welcome back to the Intermediate and Advanced Spring track. I hope you're enjoying the conference so far. I've been working with Spring for many years, and it's fun to me to see all the advancements and improvements that are announced at Spring each year. Spring Data JDBC can be a really useful addition to any Spring application for managing your data model. Schauder is here to talk about some of the less obvious features of Spring Data JDBC. I'm looking forward to hearing about how to take advantage of these. Jens, I'll turn it over to you.
Okay, so let's do another try. Welcome to my talk, Spring Data JDBC Beyond the Obvious. Looks like I hit the mute button somehow. No idea how that happened. Anyway, let's get started and let's get the ugly parts out of the way. The required legal disclaimer that whatever I tell you here, you shouldn't bet money or your company on that. Better wait until features are actually there and don't rely on me promising you something, although I don't think I will promise much. Anyway, so let's get started with the real stuff. Spring Data JDBC. I kind of hope that you already know Spring Data JDBC when you're here in this talk, but just in case that you just got curious and wanted to check it out, let me give a real quick introduction. In order to understand Spring Data JDBC, we have to first understand what is Spring Data in the first place. Spring Data is part of the Spring ecosystem, and it cares about persistence. It tries to offer a common abstraction for various kinds of persistence stores. There's Spring Data Neo4j, there's Spring Data JPA, MongoDB, Elasticsearch, and many more. And by common abstraction, we mean that things look similar. It's by no means intended that you can swap just one database out and another one in, because the feature sets of things like Neo4j, MongoDB, or relational database is so different that if you would actually put one API on top of that, you would have to limit yourself to the common set of features, which would be really, really limiting. Instead of that, we try to make things look similar so that if you've worked with one, you will easily find your way in the other and just have to learn about the special feature of that persistent store. And that is also something that is really important to us. We don't want to block your ability to use the underlying technology, even if we don't add any special features to that. Talking about special features, the thing Spring Data is kind of famous for is the ability to define repositories. Repositories is a concept from domain-driven design, and you declare them in Spring Data just by declaring an interface and then adding methods to it. And if the methods kind of speak for themselves, something like find by name, and your entity has an actual name, then it's kind of obvious what kind of query you have to generate. And Spring Data will do just that for you. But then there are many ways to query your database using annotations, or if it is a really difficult thing that we don't have special support for, you can still write custom methods where you basically can do whatever you want. So the other side of the thing is JDBC, or what's behind JDBC, relational databases. And if you're a little familiar with Spring Data, you probably know Spring Data JPA. It's by far the most popular module of Spring Data. And JPA is a technology to access relational databases. So one might wonder, why is there Spring Data JDBC? And the problem with JPA is it's complex. If you start working with JPA, start with the first tutorial, things might look simple, but actually it's really, really complex. And there are very intricate concepts that you need to understand to properly work with JPA. And as I can tell from various Stack Overflow questions, many people don't. And many people struggle with that. So people asked us, us, the Spring Data team, to create something like Spring Data JPA, but just without JPA. And that was actually the task I got when I joined the team 4.5 years ago. And the task was to create just that, but make it simpler than JPA, because I wouldn't be able to maintain anything close in complexity to JPA. And I'm the one person that mostly cares about Spring Data JDBC. Obviously, other team members will support me, but this is basically my task. So it has to be simpler. And the key idea to make it simple are strong aggregates. If you look at JPA, JPA tries to map a graph of objects or graph of classes to a graph of tables, and it basically has no boundaries, which leads to these ubiquitous question of where should I stop loading stuff, which then leads to eager loading and lazy loading and the problems associated with that. And also on the other side, you always have to wonder, what am I actually saving when I call save on an entity? And that's what you control with cascade annotations. And this is an area where Spring Data JDBC is crucially different. Spring Data JDBC makes a simple and hard decision. Whatever is reachable from the root of your aggregate is part of that aggregate and gets persisted together with that root. And it also gets loaded with that root. Just as it is kind of prescribed by domain-driven design, where the concept of aggregates comes from, they form one entity, which is a stupid term in this context, one object that belongs together, stays consistent. And if you want to reference a different aggregate, you now obviously can't use normal Java reference, because then that other aggregate would become part of the first aggregate. And instead, you just use IDs, the long or integer or whatever the ID forms. Or if you want to be a little more fancy, use an aggregate reference, which is just a simple wrapper type for an ID, which basically marks it as an ID, so you don't confuse it with a long, which might contain some monetary value or whatnot. So with that short introduction, let's look at the challenges of Spring Data JDBC. As I said, Spring Data JDBC is designed to be simple. It is intentionally limited with regards to some features. And that obviously creates challenges, because people want to use these features that they might be used from JPA or other technologies. And that's what this talk is about. We go through a couple of challenges that people encounter, basically stuff I got asked about on Stack Overflow, and see how we can solve them using Spring Data JDBC. The first one is user-defined IDs. That was actually one of the very first questions that I got asked on Stack Overflow. And in order to discuss all these different challenges, I prepared a little project. The link will be in the slides at the very end. And I have a package for each challenge, so you can also peek at what lies ahead. And we have an application, and to go with that, a set of test cases. In this case, let's start with the test cases. We are dealing in this talk always with minions, these little yellow funny guys from the various films, movies. And we have a repository of such minions. Let's take a look. And this is, if you have never seen it, how you declare a repository in Spring Data JDBC. or in general in Spring Data, you define your interface name and you extend CRUD repository with a type parameter of the entity type, which is your aggregate root, and the ID, and nothing more. CRUD repository comes with a couple of methods for surprise CRUD operations, and they will be provided to you at basically no extra cost. And we also have a string ID repository, looks the same. And let's look at the first test. This is basically how you normally use Spring Data JDBC, kind of the default behavior. You create a minion, and that minion is as simple as it gets. The only special thing is it has an ID annotation on its ID. And just as you would expect, the ID is, of course, null. And then you save it. And after that, the ID is no longer null because it gets set by the database. And proving that I'm not lying to you, the test runs just fine. But what if you want to control the ID? Or maybe the ID is already coming from a different system where you import data from and you don't want to generate a new one. Or whatever reason, you want to tell Spring Data JDBC, use this ID and none other. And what would happen if you approach this naively is you would create a minion, you set the ID, and then you call save, but then bad things happen. Because Spring Data JDBC looks at the ID to determine if this is a new entity or an existing one. And since the ID is set, it will assume, well, this entity obviously exists already. And if I want to save it again, I have to perform an update. But since it's actually not in the database, the update will update exactly 0 rows. And Spring Data JDBC will notice something is wrong and throw an exception. What you do is instead is you use the template that I skipped over in the beginning and call insert directly. The template is a JDBC aggregate template, which basically offers operations that are used by repositories internally, but that you can also invoke directly. And insert is probably the most useful one because it does the same that a repository does, with a single exception. The repository save method first does the decision, is this entity new or is it an existing one? And then calls either insert or update. And by using the template, you can always directly use insert. And it works just fine. And as you can see, we have a third case with a slightly different approach. This is the string ID minion, where you have already seen the matching repository for declared at the beginning of the test. And it's basically the same with the exception, it has a string as an ID. And you can't, at least most databases can't, as far as I know, generate string IDs in the database. So we want to do that in our application. But if we look at the code, we simply do a save. And after that, the ID is no longer null. And we can also load it. And what is going on? Well, the trick is in the setup of our application. Because in our application, which is just a straightforward Spring Boot application generated from spring.start.io, start.spring.io, And we have declared here a before safe callback. There exists a small collection of available callbacks that get called on different lifecycle stages of entities, or aggregates to be precise. And the before safe callback gets called exactly after Spring Data JDBC made the decision to perform an update or an insert, but before actually performing it. So this is a good opportunity to check, is the ID actually null? And then set it to some value as you desire. And this way, the code is slightly more complex, I guess, than the variant with a template.insert. But as a benefit, it looks exactly like with other entities, and this handling of IDs is completely removed from what normally should mainly contain your business logic. That doesn't work. So user-defined IDs, you have two options. Use a JDBC aggregate template.insert, or use a before safe callback to set the ID to a value as you desire. The next one, which is rather popular, is the question, how do we store stuff as JSON in our database? Which is just a special case, at least currently, from I have this wild structure and I want to save it in one field in the database. I don't want to take it apart and store it in some kind of relational way. It's not entities, it's just a value object that should be converted to a string, a number, a date, or something else that your database can handle. And again, we have a simple example. Again, a minion, but this time this minion has a description. And the description is just a bunch of data to have something to play around. It doesn't really matter how it looks. This is just your custom object that we, in this case, want to store as JSON in the database. We have here two maps that can contain properties, and that's it. The minion repository looks as we are used to. And let's see how we use that. We create our minion. We set a couple of these values in the appearance, a couple of other values in the personality, and we save that. And we can load it, and in the standard out, we should find that the properties get printed out, so they get actually loaded. So it does work, and the trick is just as with the previous example in the setup of the application context. Again, we have the simple Spring Boot application, but now we provide some explicit configuration, and we extend that from abstract JDBC configuration. Normally, if you create a Spring Boot application using Spring Data JDBC, Spring Boot takes care of all the different beans that Spring Data JDBC actually needs under the hood. And all that you need to provide is some kind of data source. But if you want to tweak things, just as we are going to do now, or as I did in this example, it's a good idea to extend from abstract JDBC configuration, because that already defines all these beans, and you can just override those that you want to change. And the one we want to change are the custom conversions. And we are registering two conversions, description to string and string to description, which do exactly what you would expect from their name. They take a description, or the description to string one takes a description and creates, well, not exactly a string, but almost. A JDBC value is a wrapper type which contains the actual value, which is in this kind, the string version of a JSON object, and a JDBC type, which tells your database driver how to handle that object. In this case, it's probably superfluous and overkill, and we could just return a string and make this an actual converter from description to string. But I wanted to showcase this JDBC value because if you want to control or need to control this JDBC type for your requirement and your specific JDBC driver, you can do so using just JDBC value. And the actual conversion is, as I teased this with JSON, a conversion to a JSON object get turned into a string and then passed to the database. Another small but important part is this annotation writing converter, because it tells Spring Data JDBC, or actually Spring Data in general, that this converter is used for writing to the database. And if there's a writing converter, there's of course also a reading converter, which is used for reading from the database and does just the inverse process. It gets this JSON string. It doesn't get a JDBC value as one might expect. The JSON string is basically just that what the JDBC driver offers in the result set, and it certainly doesn't provide JDBC values there. So we get a string, we pass it in a JSON object, and then we take the JSON object apart and put the values in the proper maps as desired and return that. And again, the reading converter tells Spring Data JDBC that this converter should only be used for reading. If we wouldn't have this annotation, we might end up in a situation where we try to store a string and Spring Data JDBC gets the idea that it should convert it to a description before storing it in the database, and that obviously wouldn't work in most of the cases. This support for JSON, if you want to call it that, is obviously limited. And we are right now discussing internally how we can improve on that, probably offering some kind of out-of-box converters, and probably eventually, but that is in the further future, also offer the ability to query inside the JSON objects, because right now you can query the object, the JSON structures, if you use custom query annotations, but not for like query derivation or other stuff. Okay, that's about the JSON conversions. I realized I promised to look at Slack from time to time. Oh, all these answering questions, that's really nice. There's a question about overwriting, if the before save callbacks would override IDs generated by the database. That's actually an interesting point where databases differ slightly. Most databases I encountered, if you provide a value for a column that actually is able to generate IDs, the database just goes with the value it gets provided and doesn't generate an ID. The single exception is SQL Server, which doesn't allow that by default, and it allows to enable that, but only for a single table. I found it kind of weird, and yeah, that can become a challenge if you, with SQL Server, you probably have to decide what approach you use for each aggregate. About somebody complained about blurry screen. I can't really do much about that. It's quite crisp over here, and I extra choose a low resolution, so that really should work. But maybe somebody from the team can improve that. And there's another question about JSON. To be honest, I don't understand that question. We should probably get into that in the Q&A afterwards. So continue. Quick wrap up for storing stuff as JSON in the database, or in general, converting arbitrary objects to whatever you want in your database. Use a custom type. One thing people try to do is try to write a custom conversion for maps or other collections. That doesn't work. We need a custom type. We can actually use a Java type, just collections don't work. Then we register custom converters, and we shouldn't forget about the reading and writing converter annotations to avoid problems. The next challenge, bidirectional relationships. That is something that kind of doesn't make sense in Spring Data JDBC. Because remember what I said in the beginning, and what people hopefully learn quickly when they start working with Spring Data JDBC, we have two kinds of relationships. We have relationships inside an aggregate. And these are all rooted in the aggregate root, which is, in our cases, in our example so far, always the minion. And also, everything you do with your entities, if it's not the aggregate root itself, it should still be handled by the aggregate root. So, for example, if you have a purchase order with line items, you don't just access the line item directly and change the quantity or something, but you call a method on the purchase order, and that does to the line item whatever you want to get done on the line item. But that also means the line item doesn't need a reference back to the purchase order, because it always gets called by the purchase order. And if that reference is needed, it can always provide it using just this as an additional parameter. But maybe you have lots of these methods in your code, and then you have the normal Java capabilities to solve that problems. I'll show that in a minute. The other kind of relationships are between aggregates. And these aren't really references in the first place, like not Java references, but just IDs, possibly wrapped in an aggregate reference object. And if you want to navigate from one aggregate to the other, you call the respective repository, like load this aggregate for me, please. And the other way around works just as nice. And we're going to look at that. But don't be disappointed if it's really, really simple. So again, we have a minion, and it starts as all my minions. And like, the interesting part is it has toys. It has a set of toys. And we look at that stuff below later. A toy is, again, real simple type, and it has a back reference to the minion. But that back reference is transient, and important. This is the Spring framework transient annotation, not some of some other standard Java library. And well, it means Spring Data JDBC will ignore this field. It will not try to write this information to the database. And if you forget that annotation, Spring Data JDBC will try exactly that. And in the minion, it will find toys, and the toys will have minions and so on. So that won't end well. So make sure to make these fields transient. And in order to test that the minion is actually set, we have a simple say hello method that prints out basically the name of the toy and the name of its minion. And the simple trick is what you might have already seen in the minion in the first place is the minion, whenever it gets toys set, either in the constructor or if a toy gets added by some other means, it simply adds the toy to its collection, but then also sets toy.minion to this. Plain old Java code, nothing special here. And that's kind of the thing we try to aim for with Spring Data JDBC. Spring Data JDBC should take care of persisting and loading stuff. And for everything else, do whatever you want. And if you want references somewhere, just put references in there in your constructor. Yeah, one additional note that most people that know Spring Data for some time probably know, if you have multiple constructors, you can mark the one that should be used by Spring Data with an add persistence constructor annotation. I'm not exactly sure. Oh wait, there's another constructor here, which I prefer to use in my test code. And again, this hopefully works as designed. We create a minion, we add some toys, we save it, we load it again, and we ask it to show its toys. And the toys obviously know that they are the toys of Bob. For the other case, the case of references between aggregates, again, we have, surprise, a minion. And this time it has a reference to its evil master, which is a person. And since we try to write readable code and don't want to pass longs around, just as we try to avoid just simple strings, except for the name, this is an aggregate reference. As mentioned before, it's simply a wrapper for the long. And we also have, obviously, the person class, which is just a person, nothing special there. So how do we navigate from minion to person or from person to minion? Fairly easy. If we, again, we create first a person, in this case, Scarlet, and we turn that person into an aggregate reference. Then we can create minions that reference this person, Scarlet, and That's basically it. And the other way around works just as well. If we have Stuart here, we can ask for the evil master, and that is not a person, but just an aggregate reference. And we can ask the ID for the ID, and then we would use the person repository to actually load that person. And in the opposite direction, we use find by evil master on the minions repository, which takes an ID. And we look at that method, it's again a simple and really basic Spring Data feature, an annotated query. We just load all the minions that have as evil master the given ID. Really nothing special in here, and therefore just works as one would expect. Looking at Slack, the support for Oracle databases is complete, yeah. Passes all the tests. Well, then there's some conceptual discussion if it's worth learning, if everybody's using JPA. Well, this is the case right now. I'm pretty sure in a couple of years, nobody will talk about JPA anymore. Everybody will use Spring Data JDBC, so better be early and start learning. Yeah, there's some discussion about how updates work. That's fair criticism, I think. There will be better solutions coming up for that. And more feature requests, I guess. Ollie is well equipped to answer those. They are not really that special to Spring Data JDBC. So to wrap that up, bidirectional relationships, if they're internal, just set the back reference whenever adding one of these inner entities and maintain all the references that you need. And for relationships between aggregates, just create a custom query that does what you want. And it gets even simpler, caching. If you talk to someone who is a real fan of JPA, they will tell you that they use caching and therefore JPA is fast, which is kind of a white lie. The correct part is, yes, they use caching. The somewhat correct part is, yes, it might improve performance, but the real thing is caching is an integral part of of JPA. JPA just doesn't work without caches. And caches cause problems. People get confused because they think they load stuff, but in reality, it's coming out of their cache. And all kinds of stuff. People try to write batch processes and end up with an entity manager, which is basically the cache that is totally bloated with thousands and thousands of entities. Of course, everything can be solved if you know what is going on. The problem is many people don't. The approach of Spring Data JDBC is very different. Spring Data JDBC doesn't have a cache. If you ask multiple times for the same entity, it will get loaded multiple times for you. If you don't want that, don't do that. But sometimes not doing that is kind of difficult. So having a possibility to have a cache is certainly nice. Fortunately, Spring already offers that. So let's look at a simple example to demonstrate that. Again, we have a repository of minions, and this time our minions are colored. As you might know, minions come in the colors yellow and purple, and the color is not Java AWT color or something, but color is a proper simple entity. It's actually considered an aggregate. So we create the two colors that we need, yellow and purple, and then we create a couple of minions with these colors. A couple of yellow ones and a few purple ones. And in the actual test, we load all minions. And again, color is an aggregate, so the reference is just an ID. And we iterate over all the minions. And for each one, we try to find the color and add the color with a together with the minion, or the name of the color plus the minion in a multi-valued map. So we get, as a result, a color gets mapped to a list of minions. And if we test that, the result is as expected. We get the keys yellow and purple, and the collection for yellow has size 8, and the one for purple has size 4. So nothing to be surprised about. Things just work. I mean, there's a reason why I don't type code here. But if we look at the SQL statements that actually get executed, we see obviously tons of minions getting inserted in the database. Then we get one select for loading all the minions. And then we just get 2 selects for loading the colors. And this is simply done in the color repository. Oh, sorry. Color repository, which overrides the standard find by ID method just to add a cacheable annotation in here. And we also, for this to work, we of course need to enable caching, and we have the caching starter of Spring Boot in there. And that is all that we need for a cache. For a real production application, you want a properly configured cache. I think what Spring Boot is using for tests is actually a hash map, so not really suitable as a cache. But now you have like all this stuff that you can and should do with your cache. Configure the time to live and when stuff gets injected and how much memory you want it to have. And maybe you want even something like Redis or anything that is even persistent. You can do that behind this caching annotation completely separate from the persisting, which is done by Spring Data JDBC. And I think this is the way it really should be, and not mingled up with the two shouldn't be get mingled up. So for caching, just use Spring's existing caching abstraction. And I think I've seen a couple of more comments on Slack. Yeah, there are a couple of questions. I think I'll answer them in the Q&A afterwards, and try to get the last example across which is how do I eager load references? Well, Spring Data JDBC basically did away with all this eager and lazy loading. So eager loading, what does that even mean? Well, I guess even with caching, in some scenarios, it might not help. It's great in a scenario like this one where you have like a few colors referenced by many entities. But what if you have purchase orders in many customers and you want to list purchase orders together with some information about the customers? And by default, you load the purchase order, then use the customer repository to load the customers. And even if you use that in batches, it gets clumsy and probably slow and quite expensive. So what can we do? Well, the trick is make things more explicit. Again, we have an example, a minion, surprise, with an evil master, basically the same that we have had before. And the person is a simple object. And we now imagine a situation where we actually want to list minions together with information about their evil masters. For this, we create a minion view. A minion view is just another entity. Actually, one could consider it an aggregate. And it's just a different way to look at the data, just as a database view is a different way to look at the data. You can put in here basically whatever you want, as long as it is mappable by Spring Data JDBC. I decided to extend from minion, which basically gives me all the fields of the minion, and then add the master as an embedded element. And this way, I have all the data of both aggregates in one simple package, and embedded fields get loaded with a single select statement. So this just works fine. I could now create a minion view repository and have it map to a view, or in this case, I choose to just add a method on the minion repository that returns a minion view and just spell out the select that I need to load the data. Yes, this is a little additional work, but it works just fine, as I, as usual, can demonstrate with a little test, where again, we create a person, we create a couple of minions that reference that person, and for all minions that we can load, we display their name and the name of their master. And the results look just as one expected. So I guess the point here is you don't have to have just one entity mapping to one table. You can create views either by custom queries, as I did here, or actual views in the database and map stuff to those. Just make sure that you don't use save or other writing methods, because they probably won't work. And if they would work, they probably would not do what you expect them to do. So these are obviously read-only operations, but as those, they work fine. And of course, we should look at the select statement, maybe for loading all these minions. You can see it's just one select statement with a join. So it should perform rather nicely. So again, create an entity that contains the data that you actually need, and then use either a dedicated repository or a custom method to load it. And if you use a repository, you actually have to use a view, because otherwise there's nothing to map this to. If you use a query, using a database view is optional, as demonstrated. And I'm almost out of time, which fits nicely because I'm also out of examples. The sources that I showed you are in this repository on GitHub. Oh. Spring Data JDBC itself, of course, is also on GitHub. If you use Spring Data JDBC, please do yourself a favor and you read this article, because it explains all this stuff with aggregates and references and how that works in Spring Data JDBC. That is the one thing that you really need to understand to properly use Spring Data JDBC. If you have questions about Spring Data JDBC, something not working, or you're not understanding something, ask on Stack Overflow. If something is really broken, create an issue on GitHub. And if you just want to chat with me, you can hook up with me on Twitter. And for questions, there is a different Zoom channel. And there's also Slack. And I'll move now to the other Zoom channel, which I hope you have available somehow as well. And we'll meet there and discuss further questions, and I'll try to answer them all. See you there in a minute.
Thank you, Jens, for that informative session. And thanks to our attendees for joining us for the session on Spring Data JDBC. As Jens mentioned, if anyone has questions, please follow up with them in the session Q&A room.